And an IO res. Yeah, an IO res is something that has, yeah, a result and a new world. Yeah, so this is a good example of what I was talking about. So if you want to do IO operations, you get given a single resource IO, and then the result you get back is both, firstly, the result that you wanted, right? The actual thing you asked for. But secondly, you get back a new single use version of that resource. If you could somehow, if there was some sort of uh, forbid all IO or kill IO or something, if that was, or no more IO, right? So you do a bunch of IO options and then you call the no more IO option. What would happen would, you would have a function that takes a single use world but does not return one. I mean, this is kind of obscured because you're meant to use this with the IO monad, which kind of weaves it all through. Yeah, this is a pair of a result with infinite usage and an updated world state. Yeah, it looks like it's climbing. Yeah, a single use primitive IO function, and then you get an IO operation. Why does he actually go through the run length encoding thing? Because I'm pretty sure he uses that in his example. Oh, are we going to have to get some sort of Emacs extension? I wonder what's leaking memory. We'll come back to that. Because I don't think I've configured Emacs on this computer. And it doesn't look like it's going to run. Oh, I have configured Emacs. I don't think I agree with that. I really don't like programs that chuck shit in my home directory. Yeah, where's it picking up this configuration from? Is it just reading it from my X resources? In which case, yeah, it looks like it. In which case I know it exists, because... Oh, actually, I'm not using Xterm. Yeah, that looks right. Where is Alacrity configured? Yeah, where is it configured? I have no idea. Okay. I mean, actually, now that I think about it, I don't think I've configured it at all. I think it's just using the default. Whatever. Okay, Emacs doesn't want to launch itself. That's fine. We don't need it. Linear interactive programs. We define how many times the result of an... Oh, actually, I think there's one other thing I need to do here. Yeah, we'll do the make install libdocs. Okay. To declare a data type L which describes interactive programs, we expect this to be used often. Default unrestricted usage. Interesting. It does not yet support quantity polymorphism. It's interesting. I don't know how I feel about that. Because that looks like a pain in the ass. But that's why we're experimenting. Yeah, it just keeps growing. Okay. What are you complaining about? Yeah, that's fine. The continuation type is calculated from the usage of the first action. This is a single use. Uses action. What is usage again? It's this, yeah. Right. Right, the ATM state machine. Yeah, I thought he preferred the run length encoding thing. Or was that just for dependent types? Maybe that wasn't for linear. Okay, he's got some state machine. Okay, initialize ATM. It gives you a single use ATM ready. Okay, so it gives you an initialized ATM, basically. And yeah, this is a great example of the paradigm. So you have an open function, which gives you a single use thing, and a shutdown, which consumes your single use thing, so you can't use it again. Yeah, and to insert a card to the ATM, you need to have an ATM that is initialized, right? So you need to have opened the ATM, and then it does something with this L, which I guess is indicating that you can... What's L? Keep forgetting. Where what? Where's something? Okay. Whatever, I'm gonna guess. I'm gonna guess it just tracks resource usage for the ATM. Works for me. So it gives you a single-use ATM that's in the state card inserted. And then to check a PIN, you need to have a single-use ATM that's in the card inserted. And then obviously you give it a PIN because that's part of checking a PIN. And then it gives you back a single-use session or card inserted, right? So if your PIN is wrong, you go back to the ATM being in card inserted, or well, you stay in card inserted. And if your PIN's correct, then you get an open session. Dispense, I guess this uses money. You get money from the ATM. So you need to have currently, okay, and it gives you back an ATM that you can use, single use. I don't know what they use this syntax for. It looks like it matches. It has card, okay. Right, looks like pattern matching, so we pattern match on ST. Okay, looks like it. I'm not quite sure what res is. I don't know if this is meant to be left, right, like error, result. It doesn't look like it. String const ATM ST. ST being one of these two. So do we pull ST out of here? We do. Okay. Okay, so both the ATM and has card take an ATM state. So we're just shuffling between the has card and ATM. This is for get input. Yeah, so if we display a message on the ATM, we need a single-use ATM in some state, whatever it is, and a string to display. And then what we get back is we get back a single-use ATM in the same state. All right, the state doesn't change. But if we eject a card, we go back to ready. Right, so we can't be in a session or have the card inserted if we've ejected a card. I guess res is the actual result and